if life is dominant someplace, there's just lots of it everywhere, you won't have any trouble figuring it out, even if it's very different from what we would see here on Earth. But if life is scarce, then that's when it's going to become difficult to identify what's life and what's not life. Or even if life is now extinct, like for instance on Mars, we don't see anything on the surface, but there's the question was there once life there? Well, that means at some point if it existed on Mars, it went from an abundant point to a not abundant point. So it went through this extreme environment phase as it was dying off. That dying off phase means some resource was constrained, be it a lack of oxygen or a lack of nutrient source to feed it, or there's too much radiation. There's something in there that is not what the organism needs to survive. Organisms on Earth, no matter what their type is, no matter what their size is, it doesn't seem to matter what their biology or the chemistry they're operating on, when they go through a resource-constrained environment or an excessive amount of resource, which basically means a lack of healthy situation and like too much radiation. They all go through a period you would think kind of evenly fading down, but they don't. They actually go through patterns. They'll clump up and band together to be able to survive and increase their available biodiversity. So we kind of took this and said, hey, can we use these macroscopic patterns that are appearing on microscopic organisms to be able to improve the ability to tell where to do a chemical test? So like the Mars Science Lab and things of this sort only has so many chemical tests it can do to say, was there organic molecules here? Well, what we do is we say, hey, look, let's look at the cameras. These patterns will lithify, so they'll be around for a long, long time. So can we look at the patterns in the camera to tell, is a particular area more likely than other areas to be able to have those remaining biomolecules to be able to identify life? Since your camera doesn't wear out basically in any practical time period, this is something very advantageous for NASA to look at, so they can use some of their very resource constrained things, the chemical tests, and they can kind of pick them based on other ones. But it also has some advantages on monitoring health of deserts, for instance. Soil crusts grow and they grow in patterns, and what the patterns look like can actually tell you how much rain is falling and available temperature ranges and this. So the patterns change over time. And people didn't believe these were widely changing, but this last summer we've actually been able to get some data that shows they change even on a yearly time frame. There's a lot of exciting things that can happen both here on Earth, monitoring our own environment, and also the potential for looking life out in the universe.